Welcome to our section that's entitled Information Technology and Networking. Again, we're trying to define what information technology is from a foundational standpoint and look at it through the lens of networking, computer networking. Here we're talking about the actual machines talking to each other and different components that support that and make that possible. There is a section about computer hardware and computer software, and most of you are very familiar with these pieces of the pie, so to speak. The hardware can be the tower cases that you have that hold the computer inside it with the motherboard, and laptops and iPods and iPads even that have connectivity to these devices. There's also software, and you know there's lots of software from Microsoft Office to all kinds of accounting packages and proprietary software for independent businesses to use. It's been developed for them so that they can keep their core business together and serve the public and the private sector with all the products and services that they make or produce or sell. So we have the usual things that you think of as computer hardware and computer software. But beyond this, we're really talking about computer networking. And the biggest piece of that to get your arms around and to grasp is the OSI model. You might want to Google this and look this up into some detail. OSI is Open Systems Interface, is one translation of it. You might hear some other names for the same three letters. But it's really talking about the way in which two machines have a set of standards that they must conform to no matter who produces them or how they're made or where they're made. They have to conform to this standard so that they can have proper communication with each other. There are 7 layers in the OSI model. And the easiest way to remember these layers, I should say, is by remembering this. All people seem to need data processing. And this is a great way to remember it. The letters of each word, the starting letter, the first letter, will give you a clue as to the name of the layer that is in the OSI model. That's application, presentation, session, transport, network, and then data link layer, and then of course you have the physical layer, which is at the bottom. And it starts at, it's a hierarchical model, and it starts with the physical layer at the bottom and goes all the way to the application layer at the top. You need to understand how these layers function in networking. The physical layer refers to all the wiring, the category 5 cabling, Cat5 and Cat5e, for example. It's not the only kind of wiring out there, but it's prevalent and it has the largest share of the marketplace. These refer to the copper wiring, and copper wires have limitations to them. They can only carry a signal so far before the signal weakens, and then you have to have some way to increase that signal again so it'll travel further over a copper wire. And we also have unshielded twisted pair and shielded twisted pair, STP. These are ways to talk about whether or not electromagnetism will interfere with signals. Shielded twisted pair is shielded from electromagnetic interference. So there's a lot to the physical side of this. We also have our WAN technologies, which are located at this layer, ATM and frame relay, and other types of WAN technologies, SONET, SONET, which we're going to talk about later on when we get to it. But each one of those technologies are there. And then you go up this layer to the next layer, data link layer. It's actually in two different parts. Here we have the media access control layer, the MAC address, the unique physical address that is hardwired at the factories. And you find that that's a part of what we call the NIC card, which is the network interface connection, which is located generally in the back, say, of a tower case. And that's where the Ethernet cable is directly connected into. This address is a hexadecimal address. The first three parts of it is generally the manufacturer's vendor number or identification number. And the last three is the unique ID for that particular NIC card that has been placed in the machine. Then above this we have the network layer, and this is where all the IP addressing takes place. This is where IP version 4 is directly looked at, and it is translated and understood here at this layer. Then above that we have, again, we're traveling up the layers. We could have started at the top and it might have made it easier to understand, but actually we're going to look at the next layer, which is the transport layer. And the transport layer is where we find two very important protocols, the TCP protocol and the UDP protocol. TCP is a connection-oriented protocol where a connection has to be made first before transmission of further communication can take place. And they have what this is about is called a three-way handshake. And in upper layer resources, we have to have this connection to be established first in order to transport communication. Now UDP doesn't have any. It doesn't make a connection first. It just sends the data, and you'll find that this protocol is called a connection-less protocol. Again, these are rules of communication, these protocols that I'm mentioning to you that are associated with these layers in the OSI model. Then above that is the session layer, very, very important layer in the sense that it establishes a session between the machines. And then we have the presentation layer, which literally presents the payload, a good way to think of it, what is actually being sent, like say an email or some other kind of document, actually presents this to the application layer. Now, also in the presentation layer, you can find encryption and decryption taking place. And then finally, at the application layer, you have all the things that you and I are used to using and applying in order to use our computers, our machines. We have all kinds of protocols here that we just use basically on a daily basis, and we're not necessarily aware of them being there for our use, but they're there. It's HTTP, which is Hypertext Transport Protocol, and then FTP, File Transport Protocol. We have SMTP, Simple Mail Transport Protocol for email. We have DHCP and other protocols that are running in this layer that enable us really to work with the machines and to accomplish many, many applications that we just take for granted. Now that's the OSI model in very basic form. I haven't really drilled down into all the contents and what is contained in each layer, but I'm giving you an idea of how it applies and how we use it in networking. This standard it keeps everybody on the same playing field so that these machines will talk to each other even though they're developed and created by different manufacturers with different emphasis on speed and memory and other kinds of components in the hardware. It keeps everybody, again, on the same playing field. Now, after that, you've got topologies that you need to get familiar with. And topologies are the star, mesh, hybrid, and peer-to-peer networks. There's great explanation of that in the material for you. Star is very common with the hub connection in the center, and all the machines are connected like a star pattern around the hub. You'll find many classrooms like this with computers connected to hubs, and they're like small subnets where they're self-contained, where an entire classroom can participate on the same connectivity. And a lot of times the teacher or instructor will be able to display things from his machine to your machine and everyone else's machine that he is talking about in the forms of a lecture or a PowerPoint presentation of some sort. Then there are LANs, MANs, WANs, and PANs. These are just different ways to talk about networking. A LAN is a local area network, which is contained generally in the same building or the same geographic location. And as I just mentioned, inside a classroom, you can have a small LAN inside a classroom with machines connected to each other into the same hub or the same switch, for example. Then you have MANs, which are metropolitan area networks. These are across cities, big cities, generally speaking, and you can have several offices that are connected in terms of a MAN, a metropolitan area network. You also have WANs, which are wide area networks. This is long distance here. These are WAN links or connectivity across the state or across the country or even from country to country across oceans. So these are long distance, generally fiber optic. Cabling is involved here along with satellite uplink and downlink, as well as other connectivity in the forms of large routers and switches so that traffic from major cities from state to state and from country to country can be routed correctly and sent to the proper locations where they need to go. Then there are PANs. Those are personal area networks, which is generally has to do with these mobile connectivity devices that are so prevalent today and we find in use in many business situations as well as in hotspots and so forth and so on, like at a local cafe or coffee shop or something like that. There is the issue of remote connectivity, and all businesses that have outside salespeople and people who are on the road a lot doing business overseas, for example, have to have ways to have remote connectivity to assets, to resources on the network, and usually they provide an extranet or a intranet for these people to have access to get to these resources on a remote basis. You can dial in, you can connect through the internet, there may be a VPN connection involved, or there may be terminal services of some sort to make this connectivity possible. Enterprise level networking has to do with large enterprises, large banking and financial centers, for example. And we're talking about generally hundreds and thousands of PCs and networking devices that are handling a lot of large volumes of traffic and large volumes of log on and log off every single day. They perhaps even accommodate a data center. As I mentioned, routing and switching is a big part of the internet and WAN connectivity, WAN links. Here you're talking about central offices and, companies like AT&T, Sprint, and others who are providing the routing and switching connectivity so that we can transport large amounts of data over large distances and get them to the right places too, the right PCs, also the right servers, the right networks where they belong. And so this is a central piece of how things work in the field of networking, along with satellite and telecommunications connectivity too. We also are talking about Wi-Fi and WiMAX. And Wi-Fi, wireless fidelity, is usually what you find at the coffee shops or what you can find at a home network today with the internet service providers. They have Wi-Fi connectivity in a person's home, but you can have it in a business. You can have it in a coffee shop, a restaurant. A McDonald's, for example, can have Wi-Fi connectivity. WiMAX is a larger and more comprehensive type of wireless connection, and it can reach across states. It's in development. It hasn't really taken on that much. It is a 802.16 standard. If you want to look into it a little bit more, you can get a bigger view of what's involved here. So you've got database management systems too. All businesses that are of any size have a lot to do with database management systems. They've got to have a place to to store and hold together all of their information and things like that. So keep in mind that businesses run on communication, so we have to have data centers too and storage area networks for networking purposes to make possible the volumes of information and the volumes of transactions and even the volumes of email every day possible to be distributed and also kept in either temporary storage or in permanent storage so that we have access to mounds and mounds of information that is being exchanged uh, really every single minute of every single day, almost 24 hours a day in many circumstances. So in a nutshell, that is information technology and networking. It's a really big piece. You may, again, want to use some of your resources, some of your own uh, Googling and research on the internet to fully grasp more of these ideas. You can certainly ask me questions, and I'll be glad to try and answer them as much as possible. Thank you very much, and look forward to talking to you again.